DNA or deoxyribonucleic acid has a double helix structure that is antiparallel. It has a sugar-phosphate backbone held together by covalent bonds, and it has hydrogen-bonded bases where A goes with T and C goes with G. One end goes 5' to 3', and another end goes 3' to 5'. DNA must replicate before mitosis. At the origin of replication, topoisomerase unwrites the DNA so it doesn't break, and helicase unzips the strands, forms replication bubble with 2 replication forks on each side. There are 2 different types of strands, the leading and the lagging strand. The leading strand replicates from the origin to the fork, and the nucleotides can be directly added to the 3' end of the new strand. And then the lagging strand goes from the 3' end opposite to the fork. And then on the other sides, the leading and the lagging are reversed, but they have the same concept. The next thing that happens is primase adds complementary RNA nucleotides, such as shown, and then DNA polymerase 3 adds nucleotides to the 3' end. And that's all for that section for now. So that's pretty simple. The lagging strand is a little bit more complicated. Primase adds complementary nucleotides at the end, but also in the middle, creating Okazaki fragments. And then DNA polymerase 3 adds nucleotides in the 3' direction, closer to the origin of replication, and then closer to the fork. And then polymerase 1 removes the RNA nucleotides and replaces them with DNA nucleotides. And then there's some gaps left, but the N ligase closes these gaps. Okay, then these processes repeat, and it's starting at the origin of replication on the bottom strand. And then DNA grows at the 3' end. Finally, the DNA polymerase 1 takes off the original RNA primers and replaces them with DNA nucleotides. And then after that, ligase closes the gaps.